Bienvenidos, Ushamdid, and welcome University of Maryland Global Campus learners from the CMIT-456 Section 6380 course for the Fall 2021 semester. This is the Cisco Networking Academy's CCNP ENARSI version 8 course curriculum, and in this packet tracer tutorial and activity, we're going to be taking a look at packet tracer 23.2.1, where we're going to be focused on learning about logging network activity. And if we take a look at this activity, you can see right out of the gate that there is no completion percentage down here at the bottom. So this will be an activity that we're simply going to be following through with and are following along with here. And so we're going to be creating some FTP traffic. We're going to be investigating that FTP traffic, and then we're going to be taking a look at some Syslog messages. And as you can see, we have a sniffer here in the middle of the topology. So again, we're going to be sniffing some traffic, looking at some ICMP activity and some FTP. So we're going to create the FTP traffic. So we're going to activate the sniffing device. And to do that, we would click on the sniffer. And as you can see here, there is a power switch right here. And so we would click the switch on. You'll notice that the green light comes on here. The other thing that you'll notice when you activate it is that these ports, or these triangles that were here indicating the port connectivity that were red, are now green. So we went to the physical tab. That's actually what opened up on by default. We turn the power on. Now we're going to go to the GUI tab and turn the sniffer service on. And you can see here, service is currently off. Incoming packets, we've got 2 ports from which to choose, and it wants us to use, and let's see if it tells us, and maybe port 1 is that port by default. We'll certainly find out here. So the FTP and Syslog packets entering the sniffer from router 2 are now going to be monitored. And here's where we're going to end up seeing what's going on. So let's remotely connect to the FTP server here. So now we're on to step number 2. So we're going to click on PCB, which is down here on the bottom. And let's give ourselves a little bit more room with which to work with PCB here. And let's go ahead and go to the command prompt. And from the command prompt, we're going to open an FTP session with FTP_server using its public IP address. All right, so let's just go ahead and say FTP, and the public IP address, and it wants us to use is that 209.165.200.227.
Username.
And let's go ahead and try to connect there. So now it's asking us for the username. So we're going to do Cisco and Cisco, and that gets us logged in. So let's type the dir command, which is going to give us a listing of the directory. And there you go. And as you can see, we've got quite a few Cisco iOS images that are in here. And they certainly loaded this up with some older images from the 1800 series, which were the ISRG1 routers. And you've got some really old iOS in here for the C2600, and those have been end of life for about 15 to probably 20 years at this point. So again, we see what we have in the FTP directory. And so what we're going to do here is at the FTP prompt, enter the dir command to view the current files stored on the remote FTP server, upload the clientinfo.txt file to the FTP server by entering the command put, and this is how we would put something onto the FTP server, clientinfo.txt. Now, another key thing to note here that we didn't look at before we initiated the FTP session was that this file, because I'm saying put and then the file name, would have to be in the directory from which we launched our FTP session. And there you go, 662 bytes. If I type dir again, and we're going to get a listing here, we should see 662 bytes, clientinfo.txt. Now, when we take a look at these files, what do we notice about these files? How does it list them out? So yeah, it lists them out in alphabetical order here, making it convenient for us to try to scroll down and figure out, or to take a look and see, did that file transfer, or is this file actually, does it exist here? Okay, so that takes care of that. We're going to type in quit, and this puts us here. Now, if I type dir here at the DOS prompt, you can see that there were two files there. We could have transferred sample file.txt as well, but the activity is only asking us to transfer the client info file. Maybe we'll be using that sample file.txt for something else here along the way. So now part two, right? We're going to go back to the sniffer device here, and we want to investigate the traffic that we were sniffing. And here it is. You can see the FTP traffic. Now, this is an awesome feature here of the sniffer and of Packet Tracer that's going to allow us to take a look at the actual fields in the IP, Ethernet, and TCP. You can see, right, it's really hard to see kind of, but right here it says Ethernet 2 frame, right? So here's the frame information. Here's the packet, the IP packet information, right? Source and destination IP. And here's the TCP information. It shows us our source port, right? That random high port of 1025, and then our destination port of 21 for FTP. It shows us the sequence number. In the TCP sequence, it shows us the acknowledgement number. If we come down here, let's click on the next packet and take a look at the information that we see. Again, same source port, same destination port, sequence number is up, acknowledgement number is up, and we see the window sizing here. So we're seeing a lot of interesting information, and we're seeing the FTP command information. So you're seeing a ton of detailed information here that is passing through the sniffer device. So it says click on some of the FTP packets in the session. Be sure to scroll down, view the application layer, protocol information, the packet details for each. And again, this assumes that this is your first FTP session. If you've opened other sessions, we're going to want to do the clear, which would be here. We could clear things out. What is the security vulnerability presented by FTP? Well, the vulnerability is that everything is passed in the clear, right? So the password is being passed in the clear. All of the bytes, packets, everything, all of that is being passed in the clear. What should be done to mitigate this vulnerability? Well, we would want to use SFTP or secure FTP, which is going to encrypt that information, right? And so that is the vulnerability that we're talking about. Everything is passed in clear text, and it's easy to see, right? All right, so part three here, which is going to, again, this is a very short video as we're just kind of following through. We're going to view Syslog messages. So remotely connect to router number 2. And we're going to do this from PCB. And let's definitely give ourselves some room here. And let's drop this down. So let's go ahead here, and we want to remotely connect to, so from PCB, we're simply going to Telnet, right? And so here's another protocol you probably want to avoid because Telnet also, everything is in the clear. In fact, you would have packet for packet with each of the word or letters that we type in for the password. And so to get to router 2, let's go ahead and it says NA. So it doesn't give me, and I don't think we have a host entry. Yeah, so there is no host entry. So let's jump on router 2 here and let's take a look at the CLI. And this may be part of the activity. Again, they don't have the IP address up there, but what about a show IP interface brief? And it looks like we're going to go to, if we're on PCB, and we've got that DSL modem, we probably have to come to this 209.165.200.226 is my guess. It might be this this interface. And in fact, well, we can just figure that out. Let's go ahead and get into global config. Interface gig 00, shut. Yeah, so that is the gigabit interface 00, so we'll say no shut. So now we know that gig 00 actually holds that 209.165.200.226 IP address. So from there, we can say telnet 209.165.200.226, and hopefully we're going to get the username password prompt, and I now need to see, I think it's Cisco again, is it here? The username, so it's showing all caps. Well, let's give that a go. Admin and then all caps CISCO. All right, so we are on to router 2, and you'll notice it dropped us into privilege exec mode right out of the gate. So if I was to say show run, and this is kind of a sidebar here, is there an enable password configured? Let's check and see if they've got an enable password configured. And my guess is they don't, because the privilege for the user admin has been set to 15, which means privilege exec mode. But again, there may be an enable password set, and it doesn't appear that there is. All right, so we are in privilege exec mode, and let's go ahead and do a quick debug IP ICMP. So we're going to be capturing all of the information for ICMP packets that pass through router 2. Type log out at the prompt to close the Telnet session. So now we're going to generate and view the Syslog messages. Log out of the Telnet session. I'm wondering why they want us to log out here. Give me 1 second here. Click on the Syslog server, services tab. So we're going to go to the Syslog server, and let's go ahead and set this up here. And let's go to the services tab is where they want us to head to. Verify that the Syslog, which is right here, let's make sure that it is on. It is, and you can see here the interface going up and down. And actually, that is not the interface that I just shut down, not the gig00 interface. We didn't capture that. So now we're going to go to PCB on the desktop tab, the command prompt, and it wants us to ping router. Oh, so router 2 must be configured. Hold on 1 second here. Let me say, show logging. And I'm wondering if they've got this config. Yeah, okay. So I see. I thought they wanted us to view the ICMP, the debug. I thought they wanted us to watch that live. But what's actually happening is they have us sending the debugs, the syslog messages, all the way from debugging all the way up to critical. So all messages that are being logged are being sent to the syslog server so that we don't have to watch it in real time. Although, if we did want to see that in real time, I would think that we would be able to capture that by pinging the 209.165.200.220. I'm sorry, they want us to ping the syslog server or router 2 and ping router 2. So I would think that if they wanted us to see that live, and this is what I thought they wanted us to do here, is so that we could see that, hey, take a look, right? We're getting these ICMP packets. They're coming from, I'm sorry, the ICMP echo replies, and the reply is being sourced from router 2. The destination is that it's being sent back to what I would suspect is going to be router 1 here, and we can quickly check that by simply doing show IP interface brief. And is it this 225? And it is, the gig02. So again, it's replying to the echo request, even though we're sending it from PCA. And again, if I was to do it again, you can see right over here, if I was to pull this down, right? Every time I do that, you're going to see that router 2 is sending the ICMP echo replies back to where the source IP would not be PCA. It's going to be router 1, right? And then router 1, which I'm assuming is configured for NAT. It's got to be doing NAT of some kind. Show NAT let's say show IP NAT. Show IP NAT translations. Yeah. And so what's happening here is router 1 is natting the traffic that's coming in from PCA, the 192.168.10. And you can see right here, there's all the translations. And it's translating it to the inside global 209.165.200.225. And so those ICMP packets are getting translated right here and then sent out over here to router 2. So that's why router 2, when it's replying to the destination, it's using router 1's outside interface here. And then when router 1 receives the traffic in on that interface, it sees that it's set for IP NAT outside. In fact, if we said show run, we could probably see that. Or show IP NAT outside. So, excuse me, IP NAT outside. So that interface is configured for NAT. So when that traffic comes back in, the interface says, hey, I'm configured for NAT. And lo and behold, we're doing NAT overload. So it does the we're actually doing PAT, port address translation, because of that overload keyword. So then it does the translation back to the RFC 1918 address and sends it out here to PCA. Now, again, this is kind of a little sidebar from what we're supposed to be looking at. So on the Syslog server, investigate the logged messages. And that's really what they wanted us to do. However, I think that for me is a little bit more satisfying, a little more interesting to take a look at. But here we have it, right? We're seeing the same thing, just sort of in a, the air quotes GUI syntax, right? So we're seeing what the GUI looks like here. And so here are all of those ICMP packets. In fact, if I was to continue to send these ICMP packets, we should see additional entries. And you can see there, the additional entries are filling in, and we're getting the timestamp on those entries, right? And we can see everything here if we... And actually, it's not going to allow me to change the order in which that's being received, but you get the idea. So we're seeing that traffic is being logged over to the Syslog server. Well, let's come back to router 2, because we see when we say show logging that, yeah, okay, well, here it shows that the logging's being sent there. However, what configuration was applied to router 2 to get it to log everything over there? Well, let's take a look at show run and include log. And here you go. So we've got our service timestamp set, right? But then we've got logging, trap, debugging. So we're going to be capturing any syslog messages all the way down to the debugging level, which is level 7, meaning we're going to get level 7, level 6, which is informational, level 5, notification, 4, warning, and then so forth and so on. And then we've got our logging command. And this is the command right here that is configured that tells router 2, send your messages where? Send your messages to this guy, 192.168.30.254, which is our syslog server. And so that is how the logging has been set up. Now, again, it was cool to get to take a look at this, and now take a look at what's happening here. So it's sniffing all this traffic, and interestingly enough, it doesn't ask us to look back at the sniffer again, but we've got some interesting information here, right? We're capturing all the syslog traffic that is being sent from router 2 over to that server, right? So take a look at that. We get some interesting information here. It shows us the layer 2 information, the Ethernet 2 frame. It shows us the layer 3 information, the IP packet. It shows us the UDP traffic here, right, on port 514 for the syslog message, right, the destination source port of 514. And then it shows us the application layer information, right? Let's take a look at this. The debugging level, these are debugging level messages that you're seeing here. And it tells us that, right, that's what it is capturing, that's what got sent. And as you mouse over, if you're patient and wait, you can see there that it kind of gives you some additional information. Now, this is absolutely fantastic information to know about and to sort of understand. And now remember, this sniffer here is kind of what we refer to as inline, right? It's not in sort of a mirroring mode. It's inline because it's in the direct line of the traffic. Now, if we had it hanging off of the switch over here, switch LAN 4, and if I was to pull this up very briefly, and, if the sniffer was hanging off of LAN 4 over here, and this was a span port, right, where we're spanning the traffic, or basically mirroring, and you pick a span port, like maybe, so let's say the sniffer's not here, and that this is just a direct connection, we would want to span the traffic from that port right there, right, which would then, all traffic that was ingressing or passing through this port, ingress, egress, we could have it mirrored and sent up to the sniffer on that port. Because what happens if the sniffer goes down? If the sniffer breaks, then that's going to break our traffic flow, right? So again, these are just, sort of sidebar things to hopefully add some additional points of consideration when you look at this to say, well, how would we set this up? Or, do I want to do this? Because if that sniffer goes out, and let's go to the physical port and let's turn it off. The sniffer is off. Let's come back to PCA and let's go ahead and that ping's going to work because I apologize, that's to the router. But what I want to do is go out to 229. So can I get to the Syslog server right now? And let's see here. Requests are timing out, and they're going to continue to time out because our sniffer is broken, right? So again, these are things you need to consider. Now, inside the sniffer, depending on the device that you have, and if maybe these are fiber connections, there might be what they call a little bypass switch on the inside there, where it's just a mirror that flips, and then the laser sends it out whether the device is on or not, or functional or not, right? But these are things that you'll need to consider. And again, just to prove that it's not just PCA that's having the problem, let me get off of router 2 here. And is this going to let me off of router 2? Hopefully this lets me log off of router 2. And it looks like it might not be letting me log off. Okay, there we go. So from here, remember the FTP command worked perfectly earlier. So now let's try to FTP again. Again, the sniffer is down, right? And so that is going to kill all traffic. So the final question we have here is ping router 2 from PCC. What will the destination address for the replies be on PCC? And we can leave the sniffer down right now, right? Because remember, on router 2, we are still debugging here on router 2. So let's pull this over. Let's pull PCC up, and let's ping router 2. And again, we've got an inside interface here, excuse me, that we're going to be using. And that should be, if I'm not mistaken, 192.168.40, and it should be .1. So there you go. You can see that the pings are working. And take a look here, right? What's the difference? The difference is we're pinging from the inside network on router 2. We're not pinging coming from the outside network where things are getting natted and then coming into router 2. So the source IP for the ICMP echo reply, not the echo request, which is the initial packet coming from PCC. So we see what the reply is from the router. And that's why the source is the router's internal gigabit Ethernet interface. And the destination is also an RFC 1918 address, which is PCC's address. In fact, if I was to go to the physical, go to the desktop, go to the IP config, you can see it's 192.168.40.2. And I could have probably just said IP config over here, and we would have seen the same thing. All right, well, hopefully that's given you some things to think about with respect to logging, how to monitor the logging, how to view the logging, how to do the debug and actually view the debug. And again, as always, I like to say your mileage may vary, and in a production network, I would be very, very hesitant to kick off a debug IP ICMP or a debug IP packets. Debug IP packet is going to generate a lot of information if your network is busy, and you may lose control of your monitoring window, especially if you're remoted into the device. So definitely give that some thought. All right, well, this is the penultimate packet tracer activity for the course, Packet Tracer Activity 23.2.1, Logging Network Activity. Again, I hope you enjoyed the video. If you have any questions, please feel free to ask. And as always, I hope to see you in the next video.